homework, problem number 3 from Q3Day27. You have two functions, x equals y cubed and x equals y squared, and they are asking for that region in between the two curves, and it's this region here. So there are two options we can do. Two options to use for problem number 3. Here's option number 1. So for your first option is, well, first of all, we have a problem. We have x minus y cubed and x equals y squared, not necessarily y equals. So if you want to keep that idea of that upper function, so that green one, minus the lower function, the purple one, you are going to be integrating with respect to x. So we need to change these functions in the form of y equals so that my functions are in terms of x. So for example, x equals y cubed, we take the cube root of both sides, and that becomes y equals the cube root of x. That's this green function now. X equals y squared, we take the square root of both sides, and now that is y equals the square root of x. Okay, and that's the purple function now. So if this one kind of goes with the purple and this one goes with the green, then my setup can now be done upper function minus the lower function. So area is equal to the integral from, now we're using x values. Since we are in terms of x, we are looking at the x-axis for our limits, and it goes from x equals 0 to x equals 1. So it's the integral from 0 to 1 of my new function of the cube root of x minus my new function of the square root of x. So if we want to keep that upper function minus the lower function, we are integrating in terms of x. That means that my limits are x values. That means that the function has to be in terms of x. We have a problem, or we had a problem when we had them as x equals y cubed, x equals y squared, because those variables would have been y's. We would have had a mismatch. Okay, so that was an easy fix, and now we integrate. So after you integrate this, you have x to the 4/3 over 4/3 minus x to the 3/2 over 3/2 from 0 to 1. Well, this is just area is equal to 3x to the 4/3 over 4 minus 2x to the 3/2 over 3 from 0 to 1. So area is just 3 times 1 over 4 to the 4/3 minus 2 times 1 to the 3 over 2 over 3 minus, then we're going to substitute the 0, and we've done this too many times now. We've done this part already. This is going to be 0. You guys can kind of do it in your head, or do the math in your head. And any base of 1, or any exponent that has a base of 1 will produce 1. So 1 to the 4/3, 1 to the 3/2 is just 1. So this is just 3 times 1 over 4 minus 2 times 1 over 3. So area is 3 over 4 minus 2 over 3. We need common denominators, so times 3, top and bottom, times 4, top and bottom. And we get 9 over 4 minus 9 over 12 minus 8 over 12, which is 1 over 12. Okay, so that's option 1. For option 2, we are going to look at the inverse. So, what do I mean by the inverse? Right now, x equals y cubed and y equals the cube root of x are inverse functions of each other. So x equals y squared and y equals radical x, inverse functions of each other. And if you remember that this from your previous math class, you remember inverse functions are reflections across the line y equals x. So if I reflect my function here along the line y equals x, so it's this diagonal line that cuts through the origin, then I am going to get this graph here. Okay, so if I'm going to reflect my function across the line y equals x. We get this function here, or it looks like this now. Okay, so this is option 2. So for option number 2, so this is option number 2. And by the way, we're still on problem number 3. Okay, this is just a different way to do problem number 3. Let's say you wanna keep this as x equals y squared. You wanna keep this as x equals y cubed. Well, what we have is now we have to kind of graph the inverse, because although this graph that you see in your problem says x equals y cubed is this function and x equals y squared is the purple function, using your graphing calculator, you can check and see that this is actually y equals the cube root of x. Y equals the square root of x. So if you want to use this graph, although your book labels it as x equals y cubed, and this purple graph, your book labels it as x equals y squared, go ahead and type in on your graphing calculator this function and that function. If you have it handy, you might want to check it, and you'll see that this graph, the green one actually relates to the cube root of x, and the purple one actually relates to radical x. So if you don't want to change this to y equals the square root of x and y equals the cube root of x, then you have to draw the inverse function. So you have to reflect it across the line y equals x. And now now we can go ahead and do the top function minus the bottom function. So now this is, notice that this is in terms of y. So when we integrate, now my y's, since we did the inverse, my y's are actually the limit. But if you notice, whether we're on the x or on the y, this is the y, we still start from x equals 0 to x equals 1. It just happens to be a coincidence for this problem. These aren't x, I just said they were y's. We go from y equals 0 to y equals 1. Okay? So it just happens to be a coincidence that they happen to be the same limits as in the x. Okay? So from 0 to 1, now the top function is y squared, and that's in purple. Minus y cubed, and that is in green. And this is all with respect to y now. So when we integrate this, this is actually easier to integrate. It's just y cubed over 3 minus y to the 4th over 4 from 0 to 1. And you just get 1/3 over 3 minus 1/4 over 4 and then you just go ahead and get 1/3 minus 1/4. We still need common denominators, so times 4 times 4 times 3 times 3 to finally get 4 over 12 minus 3 over 12, which happens to be the same 1 over 12. And that is it. That's how you do problem number 3. Please understand that these are two different options, okay? So all I did here was show you two different options to do problem number 3. You do not have to do both of them. If you like the way I did the first option, just stick with that. Okay, this is option 1. And just notice that regardless, we will get the same answer if it's done correctly. If you liked option 2, then go ahead and do option 2. Just understand that there are two different ways to do this problem, but you only stick with one, or you only have to stick with one, and you should be good. That is it.